All right, in this video, I'm going to go over section 4.4, continuous uniform distribution, and 4.5, normal distribution. So 4.4, the continuous uniform distribution, the PDF is defined by the 1 over b minus a. Okay, so here a random variable x is between a and b. Okay, so the reason this is a constant function, right? So the reason that f of x um, is defined by 1 over b minus a, um, not just random constant number, because the integral from negative infinity to infinity f of x must be equal to 1. That's one of the property of the PDF, right? So then, since x is random variable x is defined by a and b, so we but to change the lower limit, upper limit into just a and b, right? Okay, and then so now see f of x and dx. So now that must be equal to, you see, that must be equal to 1. Okay, so then to get 1, then f of x must be defined by 1 over b minus a, because when you plug in 1 over b minus a, okay, so then we're gonna get this. Then 1 over b minus a times x, right? So now then from ab, that is equal to b over b minus a over b minus a, which is equal to 1, right? So now we got 1, right? So and then also the we just plug in I mean from here, the to find out the what, since f of x must be constant, and to find as, let's say, c, okay, the c and the dx, then we're gonna get this c times b minus c times a, that must be equal to 1, right? Equal to 1. So now then what? C times b minus a is equal to 1, so c is equal to 1 over b minus a, right? So that's why f of x must be defined by 1 over b minus a. Okay, so now the expected value is the and then the variance is given in the textbook, and but let's see my lecture note. So here, the expected value of continuous uniform distribution function is a plus b over 2. So yeah, so using the definition of expected value, which is integral of x times f of x from a to b, evaluating that integral, you're going to get a plus b over 2. And then a variance is what? X minus mu squared, right? So, and then using the definition of variance, integral x minus mu squared, then you're going to get the b minus a squared over 12. Okay, so the simplify the integral, okay, and then take def integral. It's pretty much algebra and calculus. So then you're gonna get b minus a squared plus 12. Okay, so let's take example 4.7 in the textbook. So example 4.7, so uniform current. In example 4.1, the random variable x has a continuous uniform distribution on 4.9 to 5.1. The PDF is defined by 5. Now you see that why PDF is defined 5. Okay, it's not just randomly defined. Okay, 5 is not randomly chosen. The plugging 4.9 into A and the plugging 5.1 into B, then 1 over b minus a is equal to 1 over 0.2, which is 5. That's why the definition f of x is 5, okay? So what is the probability, the measurement of current between 4.95 and 5 milliamperes? Then we, just take a depth integral from 4.95 to 5.1, okay? So it's just algebra. And then what? The expected value invariance, just apply the formula, okay? A plus b over 2 and the b minus a squared over 12 into e of x and v of x. It's pretty much just, straightforward, right? Then what about the CDF, by the way? CDF going to be a through x and the 1 will be minus a. You just use the definition of the CDF. You can figure out the CDF of uniform continuous uniform distribution, which is x minus a over b minus a. Okay, and then this one, if x is less than a, because see, continuous uniform distribution, x is what random variable a. I mean, or we can say PDF is defined by a through b. Okay, so out of the that interval a through b, PDF is what equals 0. So if x is less than a, then CDF must be 0, and then between a and b, CDF gonna be what x minus a or b minus a, and then if x is greater than b, then total that must be equal to 1, right? So that's the all about 4. Let's see 4.5 normal distribution. What's the normal distribution? So this is really a popular, okay, the model in statistics. So the just look at this. The PDF of normal distribution has the bell is called the bell shape, which shapes like the bell shape, and then the vertical line passing through the middle of the bell shape is passed through the mean expected value of the distribution. Okay, and the symmetric about that vertical line. Okay, this is one of the main characteristic of the normal distribution. So the PDF is defined by like this: 1 over square root 2 pi sigma times e to the negative x minus mu square over 2 sigma squared. This is from the Gaussian distribution. Okay, but this is that's the beyond of this subject. Let me skip the going over about the Gaussian distribution. So the e to the x expected value is mu. Okay, and then variance is sigma square. The excuse me. So here mu is the actual expected value, and the variance is the standard deviation. Again, the sigma square is variance. And then also the normal distribution can be written as n parenthesis mu comma sigma square. So n is just initial of the normal distribution. Okay. So now let's see normal example 4.8. Assume that the current measurement in a strip of wire follow a normal distribution with a mean of 10 milliamperes and a variance of 4 milliampere square. What's the probability that a measurement exceeds the 13 milliamperes? So the problem says that the current measurement in a strip of wire follow normal distribution. So this the that current measurement is just distributed followed by the normal distribution. Okay, so we want to find the probability that milliampere exceeds 13. When the probability that measurement exceeds 13 milliamperes, it means that we gotta find the area from the 13 to infinity under that normal distribution curve. Okay, so now then how can I find out this? Yeah, so definitely you have you know mathematically, you need to take definitely integral from 13 to infinity of f of x. But you see that f of x is not kind of simple, right? It's kind of complicated. So let me show how to do using the TI-84 calculator. So in calculator, so we go to the distribution. You see that here, distribution. So press second, and then press the VARS. Okay. Then you see the number 1 and number 2, normal PDF, normal CDF. Now you understand what does the meaning of the name in synthetic the intrinsic function. So normal PDF means normal probability density function. Normal CDF means normal cumulative density function. Okay, but we want to find the probability that x is greater than 13, right? So it means that we need to find out the 13 to find the area from the 13 to infinity, right? So I know even though the name of the normal CDF is the name you see that here, the name of the second one is a CDF, but we use this one for any probability between number to number. Okay, so we just use second one. Lower is the 13. Okay, and then upper is infinity. But the calculator doesn't understand what infinity means, so we just put the some 99 some some big number such as 99999. Okay, so mu is, since the problem says that mean of 10 milliampere, so it means that mu is 10, and then sigma is just 4. as sigma is the standard deviation, right? So standard deviation is the square root of variance. The problem says the variance is a 4 milliampere square, so standard deviation must be 2. Okay, then we paste with this. Then you're gonna get 0.0668. That's the probability that measurement exceeds 13 milliamperes. Okay, of that distribution. So in the specifically, if the mean is 1 and the sigma is standard deviation is a mean is 0 and the sigma which is standard deviation 1, then we say that that is the standard normal distribution. Okay, standard normal distribution is special case of normal distribution. Okay, so now next one, let's see the following equation. See, and the figure C 4.11 summarize some useful result concerning normal distribution. This is called the range rule of thumb. Okay, it means that the 68%, see that here in the, this is the graph of normal distribution, and then 68% of the variables, okay, the variables within the mu minus sigma to mu plus sigma, which means that within the sigma, within one standard deviation, and then 95% of the random variables, values of random variable, I mean, within 2 sigma, and the 99.7% of the values of random variable within 3 sigma, 3 standard deviations. Okay, so the name of this is called the range rule of thumb, but so just this is kind sometimes it's useful to to figure out the how many the values within the sigma, 2 sigma, 3 sigma. Okay, so now next one is the standard normal distribution. I mentioned that, right? Standard normal distribution is one special case of normal distribution if the mean is 0 and the sigma square is 1. Okay, or standard deviation is 1. Okay, so we use grid letter pi right there. Okay, and then the we can transform any normal distribution to standard normal distribution using the it's not here, using the formula of z-score. So give me a second. Right there. So if x is normal random variable, which means the random variable of the normal distribution, and then e of x is mu, and the v of x is sigma square, then this is z. Okay, z value, or sometimes it's called z-score. Z value is equal to x minus mu over sigma. So that x is the random variable. Normal random variable. I'm sorry. The z is standard normal random variable. Okay, using this one, you can figure out the z value of the standard normal random variable corresponding to the given normal random variable. Okay, what I mean is this. Let me show you here. This is the example right there. I want to find the probability x equals 13 using the standard normal distribution. So you see, suppose that current measurement, this same problem is the previous problem what we saw, right? Measurement in a serial wire are assumed to follow a normal distribution with a mean of 10 millimeter and the variance is 4, which means the standard deviation 2. What is the probability the measurement exceeds 13 milliamperes? Yeah, so then, so distribution, see here, let's say this is a graph of the normal distribution of that measurement, okay, current measurement. So see that mean is 13, right? Now what are you gonna do? We wanna transform that normal distribution to standard normal distribution using that formula, z is equal to x minus mu over sigma. This one has a role transforming, I mean, the kind of role the change of variable, okay? All right, so then let's show you. Give me a second. All right, so given normal distribution with the mu equals 10 sigma 2 using that formula, okay? So the we change the normal random variable. This is normal random variable. That z is the standard normal random variable. Okay. And then, for example, it's 13 is right there, right? Okay, right there. So let's figure out the z value, z random normal variable corresponding to normal random variable 13. Then we plug in 13 into x. Then z is equal to 13 minus what's mu? Use 10 right here, and then sigma is 2. Okay, which is the 3 over 2, which is 1.5. Okay, so 1.5 is right there. So this is the z-score, or you can say z-value corresponding to the normal interval at 13. Okay. So now then, probability that x is greater than 13 can be found by transforming the normal distribution to standard. Okay. Standard normal distribution. We got this pi, and then I'm sorry, not pi. It should be p, and then z is equal to greater than 1.5. Okay. So now then, the you can use the table in the appendix in your textbook to figure out this one, or just use the rule for complement, which is 1 minus probability that z is equal to less than 1.5. Okay. So what is this? Z is greater than 1.5 right there. Okay, so the area under the graph of normal distribution from 13 to infinity is equal to the area under the graph of standard normal distribution from 1.5 to infinity. Okay, now what is this? This is probability z is less than 1.5 is what? This one. Okay, so the key in mind is, because this is the graph, what's this? Both are what? The probability density functions. It means that the area from negative infinity to infinity under the graph of probability density PDF must be equal to 1. So the area from negative infinity to infinity, which is 1, minus probability of negative infinity to here, that is equal to what? Area from 1.5 to infinity, right? Okay. So why we just use the Rupert complement? Because if you use table, look at the table in appendix. Okay. Give me a second. You see that here, cumulative standard normal distribution. So that one in the table, these values represent the area from negative infinity to, for in this case, negative for that one is represent area from negative infinity to negative 3.9. Let's see, the negative 3.99. Okay, you see, and then the the next one represent the area from negative infinity to negative 3.89. So these values represent the second decimal place number and second decimal place, and then so each values from here, see, give me a second. So this is 0.5. This is what area from negative infinity to 0, and next one is an area from negative infinity to 0.01 under the graph of standard normal distribution. Okay. You see that? So using the table, you can figure out the area under the graph of standard normal distribution from the negative infinity to the certain z value, z value. So now the but if you use the calculator, then yeah, you just simply you can figure out the figure out the probability of the normal distribution or standard normal distribution. I show you here. So using the go to the distribution. Second, go to the distribution. So using the normal CDF, because you can set lower limit, upper limit, right? So negative, example, negative 99999. You can set upper limit, lower limit, upper limit with any number, right? Or so you can set mu and sigma for any number. So if you're gonna calculate the probability of the standard normal distribution, you set 0 for mu and then 1 for sigma. Okay. If you wanna figure out the probability of just normal distribution, then just enter the value of our sigma and mu and sigma given in problems. Okay. For upper is just 13, for example, 1.5. Mu is a 0. And sigma is, I want to figure out this one. Probability is less than 1.5. This is how to do this in calculator. Okay. Now, since we set 0 for mu and 1 for sigma, so this is the what the represent that one what we calculate the standard normal distribution. Okay. So see that 0.93319. That's the what probability z is less than 1.5. Okay. For the example, let's say example 4.10 normal distribution calculation. So they just show how to figure out the probability of normal distribution using table with some technique. But once you figure out how to use a calculator, you don't have to really figure out the way. You don't have to just follow the way shown in that example. Okay, so because simply if you can figure out, you can find out any probability of normal distribution using calculator with any lower limit, upper limit, right? So I'll skip this one, example 4.10, but and then I cover example 4.11, right? So now back to here. So we got the see in this problem. We figured out the 1.5 is the z value of corresponding to x value 13, right? So actually, that z value also tell you how far uh, the your the x value from the mean using the unit, using the standard deviation as a unit. It means that 1.5 means that the x value 13 is the far away from the 1.5 standard deviations. Okay, so this many 1.5, this many of the standard deviation away from the mean. Okay, so that z value, or so that's the another interpretation of z value. Okay, so now the standardizing to calculate the probability. Yeah, so the suppose that the x is normal random variable with the mean is mu and the separator is sigma square. Then probability x is less than or equals x. We just change the x to z score at z value, and then that one is z value, x minus mu over sigma, and then x minus mu over sigma. X minus, you see the calculator, x minus mu over sigma, that's what definition of the z, standard normal random variable, right? And then lowercase x minus mu over sigma, that's the what specific z value corresponding to x value, lowercase x. Okay, let's see. So now the see example 4.12 normal distributed current. Okay, and then so the see to find out continuing example 4.11, what is the probability that current measurement is between 9 and 11? Yeah, let's figure out this one. Okay, but I'm not going to follow this one. I'll use it because I'm going to use calculator. So in calculator, and then so we go to the distribution and then use a normal CDF, and then lower limit must be what, 9. Okay, upper limit must be 11. Okay, so now and then mu is a 10, and then standard deviation is 2. So paste. Okay, then you're gonna get the 0.3829. Okay, so this is exactly the same answer as the number in a examples textbook. Okay, similarly, we can figure out the other you can to figure out the other problems using calculator. Okay, so that's the 4.5 normal distributions. Okay, so next time I'm going to cover other sections of chapter 4. Let me stop here.